Now, another way we can do this is called synthetic division. Now, this only works in certain circumstances, and I'll talk more about that in a second. So the nice thing about synthetic division is you don't have to write nearly as much. It's much, much, much quicker. Let's take a look at this box here. The box is a little confusing, and I think once we actually start getting into it, it gets a little bit easier. So if we're dividing something like ax to the third plus bx squared plus cx plus dx by some factor x minus k, and again, well, I guess I shouldn't say factor, we don't necessarily know it. This is the setup. It's got to be a linear binomial where the first or the leading coefficient is 1. Otherwise, it's not going to quite work. But we're going to follow this pattern. So there's a whole lot going on there. Let's actually just try to set this up on our own. So example 4, it says use synthetic division to divide x to the fourth minus 10x squared plus, minus 2x plus 4. Now we have, in this case, again, a missing term. We're missing the x to the third term. So we're going to say x to the fourth plus 0x to the third minus 10x squared minus 2x plus 4. And now the division part we're going to do, in synthetic division, we make a little box here, and in the box is the 0 of our divisor. What makes x plus 3 equal to 0? And that's negative 3. Now to the left, or sorry, to the right of that, what we're going to use is the coefficients of the dividend. We're going to do 1, 0 from that missing term, the x to the third term, negative 10, negative 2, and 4, making sure we keep the positives and negatives. Now we're going to give a little bit of space below it and drop a bar. Now I'm going to draw a lot more here than I normally would if I were doing this, but just because this is the first time you've done this in a while, I'm going to write out a little bit more just to remind ourselves of the process. So the first thing we're going to do is we're going to take this 1 and drop it on down below the line. That's the 1. Now I'm going to take that 1 and we're going to keep multiplying by that number that's in the box. We're going to multiply by negative 3. 1 times negative 3 is negative 3. Now we're going to add those two numbers, the 0 and the negative 3 in that column. We're going to get negative 3. We're going to multiply that by, again, that original negative 3. Again, what's in that box there? So multiplying negative 3 times negative 3, we get positive 9. We're going to add negative 10 and positive 9, we get negative 1. We're going to multiply that negative 1 by negative 3, giving us positive 3. We're going to add negative 2 and positive 3, we get 1. We're going to multiply that by negative 3 again. So again, always multiplying by that number in the upper left box. And we're going to end up with negative 3. 4 plus negative 3 gives us 1. Okay, so these are a bunch of numbers. Let me tell you the significance of these numbers. That last number is your remainder. Every other number is going to be a coefficient for what's left. So kind of working our way, and sometimes it helps us to think about it right to left. So that 1 there is our remainder. This 1 is going to be our constant. This negative 1 is going to be the coefficient for our x to the first term. This is going to be our coefficient for our x to the second term. This is going to be our coefficient for our x to the third term. In general, your highest degree should always be 1 less than we started with. We started with x to the fourth, and so now our leading coefficient, our highest degree is going to be x to the third. So it's going to be 1 x to the third minus 3x squared minus 1x, or just minus x, plus 1. And then we have the remainder of 1. But remember, we put our remainder over our divisor, so 1 over x plus 3. Folks, that's a much, much, much quicker way of doing this division. You could do this using polynomial long division. You'll end up with the exact same answer. Just it'll take more work to do long division. Let's try a couple more of these, and then we'll call it a day. So we're asked to divide the polynomial by a given factor using synthetic division and the corresponding 0, and then we're going to rewrite it in polynomial form. So, first one here, we've got 5x to the third plus 6x plus 8. It's missing the x squared term, so we got 5x to the third plus 0x squared plus 6x plus 8, and we're dividing that by x plus 2. So let's set it up. In the box is going to be the 0 of our divisor, so we're going to do negative 2. So x plus 2, negative 2 makes it equal to 0. Coefficients are 5, 0, 6, and 8. Drop a line down below. We end up with bringing that 5 down. We're going to multiply that by negative 2. We get negative 10. 0 plus negative 10 is negative 10. Negative 10 times negative 2 is positive 20. 6 plus 20 is 26. Negative 2 times that 26 gives us negative 52. 8 plus negative 52 is negative 44. So when we put that back in, we started off with an x to the third. Now we're going to be down at 5x squared minus 10x plus 26, and that minus 44 will do plus, or you can say minus 44 over x plus 2, our original divisor. One more, looking at that, 5x to the third plus 18x squared plus 7x minus 6. There's no degrees missing. We got x to the third, x to the second, x to the first, and x to the 0. So we're good to go. Now we're dividing by x plus 3, so we'll put negative 3 there because it makes x plus 3 equal to 0. We got 5, 18, 7, and negative 6. Again, the coefficients from our dividend. Drop the 5. 5 times negative 3 is negative 15. 18 plus negative 15 is positive 3. 3 times that negative 3 is negative 9. 7 plus negative 9, negative 2. And then negative 2 times negative 3 gives us positive 6. There we go. And then negative 6 plus 6 gives us 0. So we have a remainder of 0. So after we ended up dividing that by x plus 3, we end up with 5x squared plus 3x minus 2 with no remainder on the end.